Welcome back to the Building Code Pros podcast, your expert resource for navigating the world of building codes. In today's episode, we're taking a closer look at a crucial topic. Let's get started. We are diving deep into what's really the structural spine of residential construction, wall bracing requirements. Primarily, we're focusing on the International Residential Code section R602.10. For any professional, whether you're framing a tract home or maybe designing a custom build, getting this prescriptive approach right is, well, it's non-negotiable.
It absolutely is. It's the core of structural safety. Wall bracing, when you do it correctly, it ensures the structure has the horizontal stiffness and strength it needs. It needs to resist those lateral loads, think powerful wind gusts, seismic activity. We aren't just reading code sections today. We're really focusing on the practical gotchas and the design constraints dictated by R602.10, stuff that prevents catastrophic failure.
Okay, let's start at the blueprint stage then. Before a single board gets cut, you have to establish the geometry of resistance, right?
Yeah.
That starts with defining braced wall lines. These are those designated straight lines that kind of organize our bracing efforts across the building plan.
Exactly. And the braced wall line, it determines two key things for you: the total amount of bracing you're going to need and its necessary orientation. The length is measured, between perpendicular intersections, either with other interior walls or maybe the exterior perimeter. And a really critical design constraint comes up immediately in the location rules.
Yeah, I find R602.10.1.2 particularly challenging for designers, especially, when they're trying to create those big open floor plans. What are the key balancing acts we need to remember when we're establishing that line?
You need structural balance. The rule is pretty clear. No more than 2/3 of the required total bracing length can be sitting on just one side of that designated line. This basically prevents the wall from being overly stiff at one end and maybe too flexible at the other. That can induce some harmful twisting forces on the whole structure.
Right, that makes sense. And what if, say, a utility chase or some architectural feature prevents the brace panels from sitting exactly on that line? Is there any wiggle room?
Yeah, there is actually. That's where the 4-foot offset rule comes in. It's often a lifesaver for contractors, really. Individual braced wall panels, they can be offset up to 4 feet from that designated braced wall line location. But, we have to be diligent here. That 4-foot limit is firm. It's there to ensure the lateral load path is still effectively captured by the bracing system.
Okay, 4 feet max offset. Got it. So once we've established the line, we move to placing the actual physical panels. Say I have a 24-foot wall line. I can't just lump all my required bracing in the middle, can I?
Yeah. No, definitely not. And this is really crucial for preventing those huge unbraced sections of wall. We've got 2 key spacing rules to follow. First, the nearest edge of a braced wall panel has to be within 10 feet from each end of the braced wall line.
Okay, 10 feet from each end.
Right. That locks down the corners, basically. Second, the maximum distance between the adjacent edges of panels along that line, well, it can't exceed 20 feet.
20 feet max gap.
Exactly. That 20-foot gap rule forces you to break up those long open walls with some intermittent stiffness.
And regardless of how long the line actually is, there's always a minimum quantity requirement too, right?
Correct. If your braced wall line is 16 feet or less, you need at least 2 braced wall panels. They can be any length. Or you can satisfy it with one single panel, provided that panel is 48 inches or more.
Okay.
But for any line that's greater than 16 feet, you absolutely must have at least 2 panels. It's a simple initial check, yeah, but it stops you from relying on just one piece of sheathing to try and stabilize an entire wall.
Right, makes sense. Okay, so we know where and how many panels we need. Now let's get into the construction details. What are the common methods we see defined in the code? Table R602.10.4, I think. And how does a builder decide which one to use?
Yeah, the code gives you a menu, basically, of approved construction methods in that table. They're broadly categorized as either intermittent or continuously sheathed. The intermittent methods, those include things like WSP, that's wood structural panel sheathing, or DWB, which is diagonal wood bracing. Less common now, but still there.
Okay, let's maybe focus on the distinction between WSP and its continuously sheathed cousin, CSWSP. What does continuous sheathing really mean in terms of installation? How's it different?
Right. Continuous sheathing, or CS, requires structural panel sheathing, usually OSB or plywood, to cover all sheathable surfaces on one side of a braced wall line. And that isn't just the studs. It absolutely includes the areas above and below openings, like windows and doors, and also those gable end walls.
All sheathable surfaces.
Yeah. The whole goal is to create a full, continuous shear diaphragm right across the entire length of that wall line.
Okay, that sounds like it might use more material, but maybe it buys us some flexibility,
Mm-hmm.
especially when we look at minimum panel lengths in R602.10.5. That section seems like it's often the biggest constraint on, say, rough opening sizes for windows and doors.
It really is, because the minimum panel length isn't just one fixed number. It actually changes based on the wall height and the specific bracing method you're using. So, for example, a standard 8-foot wall using the common WST method, you typically need a minimum panel length of 48 inches.
48 inches, okay.
But if you jump up to, say, an 11-foot wall, that minimum required length increases to 53 inches.
Ah, okay. So where does that flexibility come in with the continuous sheathing methods like CSWSP?
This is the key insight, really, especially for walls with lots of openings, like you might find in a kitchen or a living room. With methods like CSWSP or CSSFB, that's continuously sheathed structural fiberboard, the required panel length can actually be reduced because the entire assembly is considered stronger. And crucially, the minimum panel length becomes dependent on the height of the adjacent clear opening.
Okay, hang on. So if I have an 8-foot wall and I use standard WSP,
Yep.
right around that 48 inches you mentioned, but then I switch to CSWSP, what happens? How does the opening height affect it?
Well, let's say you have a clear window opening right next to that panel, and that opening is 72 inches tall.
Okay.
If you're using CSWSP on that 8-foot wall, your minimum panel length beside that opening only needs to be 27 inches.
Wow, that's a huge difference from 48 down to 27.
Exactly. You've more than halved the panel width requirement right there. The code basically recognizes that the continuous nature of the sheathing above and below those openings helps transfer the lateral load more effectively. So it allows you to use much shorter vertical panel sections right next to the opening. This is a massive trade-off that designers, often leverage to maximize window area or fit things in tight spots.
That's a really important detail.
Mhm.
Okay, let's shift gears a bit into some higher stress situations. We need to look beyond just shear strength and think about uplift forces, particularly where the braced wall panel meets the roof structure. That's covered in R602.10.8.2, right? Connections to roof framing.
Absolutely. The code is laser focused on maintaining a continuous load path all the way up to the roof framing. The top plates of your exterior braced wall panels must be connected properly to the rafters or trusses above them. And if you're building in seismic design categories or SDCs, D0, D1, or D2, the code actually mandates specific blocking in certain situations.
Okay, can you elaborate on that blocking rule? When exactly is it required?
Sure. If the vertical distance measured between the top of your braced wall panel sheathing and the top edge of the rafters or trusses is 15 1/4 inches or less,
15 1/4 inches, okay.
then you must provide blocking between those rafters or trusses positioned directly above the braced wall panel below. This ensures that any uplift forces trying to, lift that wall are immediately transferred into the roof diaphragm structure.
Got it. And if that distance is more than 15 1/4 inches?
Well, then you need different details, like soffit blocking panels or maybe vanicle blocking panels. The code figures show how to do that. It's all about ensuring that connection.
Okay. This brings us nicely to a major potential weak point, especially in high-risk areas. Cripple walls, those short foundation walls. They're historically where structures can fail in an earthquake. What special rules apply under R602.10.10.1 for cripple walls?
Yeah, the rules tighten up severely for cripple walls, specifically in SDCC, D0, D1, and D2, and also for townhouses in SDCC. First off, your bracing method choices are strictly limited. Down there, you can only use WSP wood structural panel and CSWSP, the continuous version.
Ah, okay. No lead-in bracing, no gypsum board methods allowed for cripple wall bracing in those zones?
Correct, just wood structural panels.
So fewer options and probably tighter installation requirements too. Does the spacing change down there as well?
It does, significantly. The maximum distance allowed between the adjacent edges of braced wall panels on cripple walls is dramatically reduced. It drops from the standard 20 feet allowed on upper floors down to just 14 feet.
14 feet max gap. Wow.
Yeah, the code really wants more continuous bracing, closer together in that critical zone near the foundation. And furthermore, there's another big one. If you have interior braced wall lines up above that are not supported on a continuous foundation below, which is pretty common actually, then the required bracing length for the parallel cripple walls supporting them must first be calculated, and then that length has to be multiplied by 1.5.
Whoa, hold on. A 50% increase in the required bracing length.
Mm.
That could be really hard to achieve, maybe even impossible in a remodel or a house with limited foundation space.
It certainly can be. The code does provide an alternative, thankfully. If you simply cannot achieve that increased length, you can instead choose to increase the shear capacity of the panels you do have room for. You do this by tightening your fastener spacing down to 4 inches on center.
Okay, tighter nailing.
Right. And if you do that, you can then adjust the required bracing length by multiplying it by 0.7 instead of 1.5.
Ah, so you reduce the required length but make the panels much stronger.
Exactly. It's a really crucial trade-off. Use less total length, but make the bracing panels you do install significantly stronger with closer nailing.
That's a critical option to know about. Okay, so for our audience who might be working on smaller, maybe more straightforward structures, there is that entirely different approach. Simplified wall bracing. That's in R602.12. Why would a professional opt for this simplified system, and what's the biggest functional difference compared to the detailed R602.10 method we've been discussing?
Yeah, R602.12, the simplified method, it's really designed for, well, speed and simplicity, as the name suggests.
Right.
It's often ideal for things like detached garages, maybe simple rectangular additions or small, fairly square residential footprints. The biggest functional difference, and this is key, is that you absolutely cannot mix and match these rules with the detailed R602.10 requirements we've been talking about.
Oh, okay, so it's all or nothing.
Pretty much, yes. If you choose the simplified path, the entire building has to comply with all the R602.12 criteria. There's a small exception for mixing with portal frames in R602.12.6, but generally you stick to one system.
Okay. And how does the calculation itself work differently? Is it still based on wall lines?
No, it moves away from calculating linear feet of bracing per wall line. Instead, it operates using something called bracing units. And these are based on the overall geometry of the building plan specifically, the circumscribed rectangle around the whole plan. You basically look up values in tables, like table R602.12.4, and you determine the number of bracing units required based on your local wind speed, the number of stories, and the ratio of your building's short side to its long side.
Interesting. That sounds like it might also imply some major restrictions on the materials you can use too, doesn't it?
It does. The material requirements for simplified bracing are very strict. You basically have to use minimum 3/8 inch thick wood structural panels or minimum 1/2 inch structural fiberboard sheathing.
Okay, limited choices there.
Right. It takes a lot of the complexity out of the calculation by limiting your design choices, but it makes the math much simpler if your building fits the criteria.
Okay, let's try and synthesize the main R602.10 rules we discussed earlier with a quick practical example. Let's imagine we have, say, a 30-foot braced wall line. We're in a moderate wind zone, maybe SDCB, nothing too extreme, and we want to use the common WSP method on a standard 8-foot tall wall. How does that play out?
Okay, 30-foot line. So, first check. It's over 16 feet long. That means you need a minimum of 2 braced wall panels along that line.
Right, 2 panels minimum.
And since it's an 8-foot wall using WSP, each of those panels needs to be at least 48 inches long.
Okay, 48 inches each.
Now, placement. The first panel's nearest edge must start within 10 feet of one end of that 30-foot line. Let's say you put a 48-inch panel starting right at the 10-foot mark from the corner. That panel uses 4 feet. So you started at 10 feet and at 14 feet. Now you have 16 feet of wall remaining until the other end. 30 minus 14. Your next panel must begin such that its leading edge is no more than 20 feet from the trailing edge of that first panel.
The 20-foot gap rule.
Exactly. So the trailing edge of the first panel was at the 14-foot mark. You can have a gap of up to 20 feet before the next panel starts. So the next panel could start as late as the 34-foot mark, but our wall is only 30 feet long. So in this case, that 20-foot gap rule doesn't really constrain you much beyond the 10 foot from the end rule for the second panel. You just need to make sure that second panel is also within 10 feet of the other end of the line.
Right. So you need a panel within 10 feet of the start and another within 10 feet of the end. And they both need to be 48 inches.
Correct. And the distance between their adjacent edges can't exceed 20 feet. In this 30-foot example, it works out pretty easily. But you can see how those rules force the builder to distribute the stiffness efficiently across that 30-foot span, dictating where windows or doors can realistically go.
That provides fantastic clarity. Okay, for everyone listening, let's quickly recap maybe the 3 or 4 most critical takeaways from navigating R602.10. What should people really remember?
Yeah, good idea. I'd probably highlight 3, maybe 4 foundational pieces of knowledge you really have to carry with you. First, panel location is mandatory, not optional. You really have limited design wiggle room here. Never forget the 4-foot maximum offset from the designated braced wall line. And critically, that 20-foot maximum gap allowed between the adjacent edges of your braced wall panels. Missing either of those basic placement rules can invalidate your entire bracing scheme.
Okay, location and spacing limits. Got it. What's number 2?
Second, sizing depends on the system. That 48-inch minimum panel length we keep mentioning for an 8-foot wall, that's just a baseline for intermittent methods like WSP. Remember, if you switch to continuous sheathing, the required length can shrink dramatically, especially when it's placed next to shorter openings. You always need to reference the minimum panel length tables based on your chosen method, the wall height, and the adjacent opening height is applicable.
Right. Don't just assume 48 inches works everywhere. Okay, and the third?
Third, cripple walls demand respect and often overbracing. If you are working in a seismic zone or dealing with townhouses and SDCC, remember those limitations kick in. It's WSP or CSWSP methods only down there. The max panel spacing drops significantly to 14 feet. And if you lack continuous interior foundations below, you absolutely must address that 1.5 multiplier, either by finding space for more bracing length or by tightening your fastener schedule down to 4 inches on center and using the 0.7 adjustment factor. Don't ignore cripple walls.
Excellent points. Location, sizing isn't fixed, and cripple walls need extra attention. Anything else? Maybe a final thought?
Yeah, maybe just this. The code fundamentally heavily favors creating a continuous load path. While all these tables and rules provide prescriptive solutions that work, always try to be conscious of the actual path those forces are taking through the structure, particularly in areas that might be susceptible to uplift or high lateral shear. Understanding these specific IRC rules allows you, the builder or designer, to build stronger, much more resilient structures right from the foundation up. It's about ensuring that box stays rigid when pushed.
That's invaluable advice. The prescriptive rules in the IRC, they exist for a reason, to ensure that when those horizontal forces hit, whether it's from wind or earth, your structure acts like a unified box, not, a stack of cards ready to topple. Understanding these specifics really helps. And that's our breakdown for today. We hope this gives you a clear understanding of the topic. For more articles and resources, be sure to visit buildingcodepros.com. Join us next time for another episode. Thanks for listening.